to Epsilon Pro Academy. In our previous lesson, we talked about function of a function, the concept of a function, and derivation. So to obtain a proper knowledge, it is advisable to watch our previous video if you missed out. In this lesson today, we are going to consider product rule. In a function of a function, product rule means multiplying a function with another function. So the simple trick is that whenever you come across the term product rule, the first thing that should come into your mind is that a function is being multiplied by another function. For example, y is equal to, in bracket, 5x raised to the power of 4 minus 2x squared, then times 1 plus x cubed. Another example is that if y is a function of x, then y is equal to x raised to the power of 7 sine 4x. Another example is y is equal to 4x raised to the power of 3 in bracket 2x squared plus 3 raised to the power of. All these are examples of product rule. So when a function is being multiplied by another function, a bracket multiplied by another bracket, and when it comes to product rule, if this type of question is given to you, it is expedient you don't expand. So we are not basically multiplying this bracket by this bracket. There's a principle and a rule which could be used to solve this. Now take note of this. In product rule, the case is quite different from what we obtained in chain rule. That was in our previous video. So if you are looking at this equation given to us, we observe that it is always a particular term times another term, a function times another function. That is all about product rule. So in a product rule, y is always a function of u times v. Y is always a function of u times v, where u represents the first product term and v represents the second product term. Considering the first example on the board, y is equal to this bracket times this bracket. That means y is equal to u times v. And if y is equal to u times v, that means that this first bracket represents u and the second bracket represents v. Now if you are considering the second example on the board, where y is equal to x raised to the power of 7 sine 4x, that means the product is x raised to the power of 7 times sine 4x. And if we are to represent this in this form, where y is equal to u and v, that is to say x raised to the power of 7 becomes u and sine 4x becomes v. Likewise to this, y is equal to 4x raised to the power of 3 and this bracket. So that becomes the product of 4x cubed and this bracket. If you are required to represent what is written here in this form, where y is equal to u and v, the first term, 4x raised to the power of 3, becomes u, and the second term, which is the bracket, becomes v. So in product rule, the first thing that must be obtained is that those two quantities must be separated, and one of them will be represented with letter u, whereas the second will be letter v. Now, having known that, let us consider the general formula for product rule. In product rule, if y is a function of x, as written on the board, then the derivation of y with respect to x is going to be given as u, then dv over the x plus v then du over dx. This is the general formula for product rule. General formula for product rule. Now, before we can solve example 1, 2, and 3, we have to consider this general formula, and also we have to recall the general formula for derivation, where we stated that if y is a function of x, then dy over dx will equal to multiply the power by the coefficient a and then subtract 1 from the power. So having to know these two formulas, let us solve the question on the board. Question number 1, 2, and 3 respectively. Let's consider the first example on the board, where y is a function of x and y is equal to, in bracket, 5x raised to the power of 4 minus 2x squared, then in bracket 1 plus x cubed. Now the first thing we have to obtain is that we will put this into this form. So that means y will equal to u and v, u times v, the product of u times v. Now that means u is equal to 5x raised to the power of 4 minus 2x squared, while v becomes 1 plus x raised to the power of 3. 1 plus x raised to the power of 3. Now the next question is, we are required to get the v over the x from the general formula given. Another one is, we are required to get du over dx also in this general formula given. It was stated in our previous video that whenever a derivation of a particular function with respect to another function is given to you, that set of equation must comprise only two letters, which is what is given to you, dependent variable and independent variable. The derivation of u with respect to x is going to be an equation that comprises of u and x. Having known this, the derivation of v with respect to x is going to be a set of equations on the board that comprises of v and x, dv over dx, v and x. So the derivation of this function becomes dv over dx. Therefore, dv over dx will equal to, applying this formula, we have the derivation of a constant term becomes 0. So that is 0 plus, and the derivation of this becomes the power times the coefficient. 1 times 3 gives 3. Then x, subtract 1 from the power, which is 2. So which equal to 3x raised to the power of 2. Again, let's consider the v over the x. To find the derivation of u with respect to x, we have to consider a set of equations that comprises u and x only. So that is u and x. The derivation of this function becomes du over dx. Applying the derivation formula to this, we obtain the power times the coefficient. 5 times 4 gives 20x, subtract 1 from it, becomes 3, minus 2 times 2 gives 4, then subtract 1 from the power, it becomes 1, and that becomes the final result. So what is dy over dx? dy over dx would give dy over dx is going to give u, and u is given as this. This is u. So it's 3x squared. So 3x squared plus v. And v is given as 1 plus x cubed. So that is 1 plus x cubed. Then times du over dx. And du over dx is 20x cubed minus 4x. 20x cubed minus 4x in bracket. So dy over dx, dy over dx could be multiply this by this. I'm going to obtain 15x raised to the power of, then add their powers, which is x raised to the power of 6, then minus 3 times 2 is 6, 6x raised to the power of 2 plus 2 is 4, then plus 1 times 20 gives 20x raised to the power of 3 plus 1 times minus 4x gives minus 4x plus x cubed times 20, x cubed gives 20x raised to the power of 6 plus x cubed times minus 4x gives minus 4x raised to the power of 3 plus 1 is 3. So by collection of like terms, we can obtain, now let's expand the bracket and also collect like terms. So this is x raised to the power of 6, x raised to the power of 6. So we are adding these two together, and that will give us 35x raised to the power of 6. After x raised to the power of 6, the next is power 4, so minus 6x raised to the power of 4. Again, the next is power 3. 20 plus 20 minus 4 gives 16 plus 16x raised to the power of 3 and minus 4x. So this becomes the final result. Let us consider the second example on the board under product rule. And the question on the board is y is equal to x raised to the power of 7 sine 4x. In this example on the board, it is basically the combination of chain rule and product rule. And in this case, one has to be very careful. So the first thing we have to obtain, or the first thing that must be done when we are talking about a product rule, is that we must represent the set of function given or equation given in the form of u times v. So that means I will equal to u times v. So if y is u times v, that means in this case, x raised to the power of 7 would represent u, and sine 4x is going to represent v. So that means u is equal to x raised to the power of 7 and v is equal to sine 4x. That is the first approach. Again, considering the formula given to us, dy over dx is equal to u dv over dx. Now the concept is that if we are required to determine dv over dx, we must consider that equation that is made up of only letter v and letter x from what we have gotten so far. Now, dv over dx should be determined using, this is the only equation that comprises v and x variables, while this one is u and x. So when we are talking about du over dx, you consider u and x. Now we are considering dv over x because this equation is made up of v and x. So take note of the concept. Dv over dx is dv over dx will equal to, now take note of this. There's a little big problem here, but the problem is something that we can handle, and it's something that we have handled in our previous lesson when we talked about chain rule. So in our previous lesson, when we talked about chain rule, we discussed how to identify a question under chain rule, some examples of chain rule, and this is one of it. Now, to have a proper understanding, watch the previous video we did under chain rule. Okay, in our previous video, when we were discussing about chain rule, the dependent variable at this point was y, while the independent variable was x. That is to say, y was expressed as a function of x. So we are going to solve this with regard to what we did under chain rule in our previous lesson. So let us say that let v represents y. So let v represent y, or let y represent v. So if that is so, then y will equal to sine 4x. Y will equal to sine 4x. We are going to solve this using the method of chain rule. Then the result will become dv over dx that we are looking for. So in chain rule, it was stated that if a function is given to you as what is written on the board, the group of x, or the family of x, or all the term that is associated with x should be represented using letter u. So that means y will equal to sine 4x becomes u sine u. So if 4x is u, then u will equal to 4x. U is 4x. Haven't known this, let us record the formula for chain rule. In chain rule, dy over dx is equal to dy over du times du over dx. This is the formula for chain rule. Now, dy over du is the derivation of y with respect to u. That means the set of equations that will be considered as dy over du on the board is the equation that is made up of only letter y and u. So that is y and u. So to find the derivation of sine u, we have that dy over du is equal to cos u. We are done with that part. Now the next is du over dx. So we are considering this u and x. So du over dx, du over dx will give us 4. If you find the derivation of 4x, we obtain 4. Okay, so dy over dx, dy over dx will equal to dy over du times this, which means cos 4. And cos u times 4 will give me 4 cos u. Let's substitute now. What is the meaning of u? What does u represent? U is equal to 4x. So because u is 4x, then dy over dx, which is the same thing as dv over dx, will give me 4 cos 4x. 4 cos 4x. That is very simple. Okay, so dv over dx becomes 4 cos 4x. We have gotten this. Now the next is du over dx. The derivation of u with respect to x is a set of equations that must be considered from what we obtained in this product function given. So that means du over dx becomes the derivation of u with respect to that of x in this equation. So we have du over dx as, if you apply the derivation formula, we are going to obtain 7 times 1, because 1 is the coefficient of x. So 7 times 1 is 7, then subtract 1 from the power. So we have 7x raised to the power of 6. Haven't known this, we can apply the general formula for product rule, dy over dx. And dy over dx is equal to u, and u is given as x raised to the power of 7 times dv over dx, and dv over dx is this. So we have 4 cos 4x plus v, and v on the board is sine 4x. So we have sine 4x times du over dx, and du over dx is 7x raised to the power of 6. So generally, dy over dx is equal to x raised to the power of 7 in parentheses 4 cos 4x plus, over here, 7x raised to the power of 6 in bracket sine 4x. And this becomes the final result. Let us consider the next example on the board. This example on the board is also the combination of chain rule and product rule. One has to be careful when solving this type of question. Now, the first thing we have to do is that we have to represent this function in the form of v times u. Yes, so solution y will equal to u times v. U times v. Now, if you are comparing what is written here to what is written here, we observe that there are two functions, 4x raised to the power of 3 multiplied by this bracket. If that is so, 4x raised to the power of 3 becomes u. So u equal to 4x raised to the power of 3. And v equal to, in bracket, 2x squared plus 3 raised to the power of 9. That is the first approach. Then again, we have to determine the derivation of v with respect to x from that general formula given to us. And dv over dx. When we say dv over dx, we are considering the function that is made up of only 2 letters, v and x alone. So that would be this function, v and x alone. But there's an observation. In this function where v is equal to a bracket raised to the power of 9, we can only achieve the derivation of this function by the method of chain rule. In our previous video, we discussed how to determine a question under chain rule. So take note of this. If you haven't watched the video, for a proper understanding, go and watch our previous video. In our previous video where we talked about chain rule, y was completely expressed in terms of x. That is to say, y was a function of x and v was not a function of x. So with regards to what we did in the previous video, let us change this v to y by saying that let v be equal to y, or y be equal to v. So let v represent y, or let y represent v. And if v is y, and y is also v, then the equation could be y is equal to bracket open 2x squared plus 3 raised to the power of 9. That is just the concept. Now, having known this, we can express this in terms of chain rule. Now, one of the concepts of chain rule is that all the independent variable, that is x, family of x, must be represented with a letter which is u, capital letter U. So if that is so, then y will equal to, this is the family of x. So it becomes u raised to the power of 9. Because we are using this u to represent the bracket, then we can say that the bracket or u is equal to 2x squared plus 3. At this juncture, let us find the let us find the general formula for chain rule. So in chain rule, since y is a function of x, then dy over dx will give dy over du times du over dx. Now, how do we obtain dy over du? To get dy over du, let us look for the equation here that has only y and u as the letter in the equation. So we have this. So to find the derivation of this, it will give me, remember the general formula for derivation, that you must multiply this person by the coefficient. And that is 9 times 1, which is 9. Then subtract 1 from it. So we have 9u raised to the power of 8. And this gives over du. Now the next is du over dx. So we are considering this equation with u and x. So to find the derivation, we have to apply the derivation formula to this and also to this. Take note that the derivation of a constant term, 3, will give you 0, always give you 0. 2 times 2, which is 4, then x, subtract 1 from it, it remains x raised to the power of 1. So this is du over dx. dy over dx becomes dy over du times du over dx. So that means dy over dx will equal to 9u raised to the power of 8 times 4x. So that will give 9 times 4 is 36 u raised to the power of 8x. The next is to substitute. So u is equal to 2x squared plus 3. So that gives that dy over dx is equal to 36 in bracket 2x squared plus 3x is the final solution for dv over dx. So dv over dx, from this formula, dv over dx was meant to be determined using the method of chain rule, which we did, and we obtained 36 in bracket, or could be 36x in bracket 2x squared plus 3. So take note of this. Either 36x times this bracket. So let's determine du over dx. Du over dx becomes this function, the derivation of this function on the board, du over dx. So du over dx is equal to, multiply the power by the coefficient. 4 times 3 gives 12x, then subtract 1 from the power, which is 2. Okay, so dy over dx on the board is equal to u. Dy over dx is equal to u, and u is given as 4x raised to the power of 3. 4x raised to the power of 3 times dv over dx, and dv over dx is this. I told you that this could also be written as 36x times this. So let's use 36x, then in bracket 2x squared plus 3 plus v on the board is this bracket. So 2x squared plus 3, 2x squared plus 3 raised to the power of 9 is 12x raised to the power of 2. Okay, at this point, I observed that this was 36 you raised to the power of 8. So it was meant to be 36x raised to the power of 8. So this is raised to the power of 8, raised to the power of 8, and raised to the power of 8, and okay, so that is it. So dy over dx, this could be the final result, or you can further multiply this by this to obtain 4 times 36 gives 144. Then x raised to the power of 3 plus x raised to the power of 1 give x raised to the power of 4. Then 2x squared plus 3 raised to the power of 8 plus, over here, it remains 12x squared in bracket 2x squared plus 3. So this becomes the final result. If this video was helpful to you, click on the like button, share this video to others, and also remember to subscribe if you haven't subscribed. Also, in our next video, we are going to consider one of the most important rules of differentiation, which is the quotient rule. See you in our next video.